I am ready.
Okay, Ali, please start.
Okay, just a moment. Okay, now see my screen.
Unfortunately, no. Okay, now we can see.
Okay,
Okay, please start.
okay. Classification, gender, age, and race together. Uh, Introduction. The face of a human hold a a significant amount of qualities and the data about the human identification. For example, uh, appearance, race, gender, classification, and age. Uh, Humans can identify and examine this data effectively. Most of human can peer give human attributes like gender classification, and they can uh, judging of if the human is male or female by just uh, obs- uh, observing face. They can estimate the age of the individual and state whether this and individual is a kid or uh, a grown up without adopt most programmed official uh, charac- uh, characteristics uh, characteristic. Yes, arrangement from works depend on machine vision and machine uh, 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 analog document. Computer vision in group rates uh, strict and prosperous for com, com, comparison, breaking down and removing data from pictures. The blind of machine uh, analog document from work includes three principal parts, which are pre-handling, uh, high highlights, extrication, and order. Uh, Age predicting gender classification and race forecast from works has been developing quickly as of late day. It's sign funct models and available uses for some machine vision application in seeing a particular portion of individuals, estimation of gender and age forecasts from works are presently being utilized by Lodgings air terminalize transport station club government station. Yes. Colgates, clinics, films, and so forth to apply the degree of security and teaching any potential rest or task in the security app age and gender for this methods are utilized like is in social and strengths from works data recovery secondary examination and investigate and customers are conveyed to version gender classification and age gather J-things like young stairs. Adults can't old citizen and senior old citizen notwithstanding deeds of the male of female. Now talking about gender classification, a particular number of parameters are needed to process with the gender predication. Figures 1, this demonstrates the used features of gender classification about eyes, noise. Yes, gender classification parameter. Now talking about age estimation, the feature of the princess face have consists of two features, shape and facial scan text features, drawing the channels and the age from childhood to adapt the shape features also changed considerably. The shape features are very helpful for estimating the age of adults instead of babies. On the other hand, the visual scan texture features are more efficient to differentiate between adult and senior adult. This text and shape features are provide useful information for estimating age. Therefore, facial texture and shape features are used to develop age estimation face. And now talking about race classification, the race identification methods are used to extract standardized information from face picture. The CNN classifier is classified for distinguishing the race. Yes, and now convolution neural network classification. It's takes place in the main step gender classification first and defect two. The gender of source image, the source image forward to the age classification to identify the relative age order, um, and forward to the race classifier to classify the race. Gender classification is basically using the facial features on features of face, age, range, based on vertical analyze face angel and the classification of the race. And the identification process completed by utilizing calculate parameters of convolution neural network. The parameter are sent to CNN to classify the image per gender, age, and race. CNN used for gender prediction having 5 input and 2 output nodes, 0 and 1. Yes, revealing the two genders time, males 0 and feminine 1. Output worth from the convolution neural network is employed to classify the image into on amongst the gender times. The neural network want to classify the giving input image in to a corresponding age bracket has 8 input nodes, and also the output layer contains 4 needs particularly 0, 1, 2, 3, 4, and 5 to responsive. The age teams 16, 13, 15, 17, and 19, and 100. 16 respectively. And this figures neural network frameworks for age, gender, and race classification. Now go to the workshop, and I this workshop in using two convolution layer, but now I update this like this. Yes. Now conclusion. Automate verification and identification of face from facial image to about good accuracy with a high data set of training and testing to using face attributes from image is still challenging. Hence, processing frequent and accurate facial image identification and classification based on official attributes is an important task. The prediction from human face image is much more complex. The work for automatic gender, age, and race classification is based on facial features and CNN. Can use the physical appearance of the human face to predict age, gender, and race. The methodology is gender, age, and race. On this reference, now go to the workshop. I update
Okay.
my.
Okay, Ali, I have one notes. Thank you. I think it is great, and I mean you have a lot of results every week, but I think you should let's start by creating your semester report similar to last semester. Okay. And please show us in a report plan with all your results for next week. Okay.
Again, please, Professor.
Okay. Do you hear me?
I hear you.
Okay. First of all, I think it is really good. I mean, you have a lot of results every week. It is really great. Okay.
Yes.
Next, I think you should start design semester report. Similar last semester. Did you remember semester report? Ali.
Yes, yes, I remember.
Okay. And I think we should discuss a report plan. Yes, for next week. Okay. Can you show next week your structure of semester report? Okay, and we discuss it. Okay.
Okay, but what do you mean the plan?
Plan. It is a structure of your report. You have, for example, state of the art, next methodology and methods, and maybe some results of your design workshop in this semester. Okay. Okay, I can clarify. You should create a big a big report about all of things which
okay.
you do in this semester. And I think you have a lot of results for today. And I think you should start created the structure of your semester report. Understand?
Yes, now I understand. Yes.
Okay, okay.
Yes.
I think it is to create a really good report which you can create it, this report in 2 weeks in April and in May. It is really important to create good report
Yes, of course.
for your future for your master thesis. Okay.
Yes, okay.
Okay.
Thank
And
you.
please continue.
Yes. Where this? Yes. Professor Zuzin, with me?
Yeah, I hear.
Hello.
Hello.
I update my convolution layer. I added 3 and added budding 2.
Okay.
Yes, but I try more change in choose this change here and change this LR more time. Now this my result.
Yeah. I guess everything is correct here.
Yes, but I think not clear got because not curve above or under. How can I change this result?
You mean how you can choose correct weights for your model or what? You have two curves, test loss and train loss. You can see that the best model in
Yes.
okay in point 3,000, yeah, or 300 of thousands, yeah. This is the best model because the test loss is minimum here. So I guess that the best way is
I send you this link.
okay, you can send it.
Yes, just a moment.
And it should be noted that in your reports the figure 2 is not correct.
I think I have a problem with my message.
Okay. Okay, we can discuss in the next lecture maybe is the problem, or you can send me today on the mail or in Telegram.
Yes, yes, maybe.
Okay, I guess that we can discuss just the figure 2 in your report because it is not correct, I think. Maybe it is not correct.
Fine. Just a moment. No.
Okay, I can
Fine.
write.
No. Maybe.
I hope that this idea should be clear for all. Right here. Okay, in your figure, you made mistake. Yes. It should be noted that one moment, that if you train your model, you input some RGB image, RGB image, and after convolutional layers, you will get some feature maps, you remember it, some feature maps, and you, okay, write like this. This is a convolutional neural network. You will get some feature maps with size smaller than your initial image, and after this you flat all feature maps into one-dimensional array, like this. So all feature maps like one-dimensional array, and this is called feature extractor. It is a feature extractor. And after feature extractor, you can use classificator. You correctly draw it that it is some fully connected neural network, and each feature using this neural network. Okay, maybe it is not good. Sorry, like this. Like this. All features using as input for classificator, and using this neural network, you can classificate, for example, gender. You use the last two neural network for, last neurons for classificate For example, gender, yeah, it is a male or female here, yeah. So in this scheme, you can ask, you can tell that this feature vector, this one, it is a gender features, yeah, gender features, yeah, it is a correct features, which was extract from image. You extract some feature vector from image, and you use this feature vector for classificate gender. Of course, you can write again maybe with another scheme. Yeah, you have the same pictures, some convolutional neural network, and you extract some another vector, and you use classificator for instance race prediction. Yeah, so the same things. You have fully connected layers, and you predict race here. Yeah, it is a first, second, third, and fourth class. It is a race. Yeah, race. And yes, you can say you can tell that this feature vector is a race features which were extracted from images, from image of face, but these examples correspond to model just for age or race or gender classification. But the main idea that when you combine together classificator means that you input your image vector. Here is some convolutional neural network. You will get the same feature. Okay, let's write this feature vector, and you can use this feature vector for both tasks. For instance, here will be okay, let's write like this, for example, female and male. Like this here. You use this vector for it is a gender classification, this one classificator, and you have another classificator for the same thing. Please understand, yeah? This race 1, 2, 3, 4, and you use the same feature vector for race classification, and you can see that this feature vector is common for both tasks. Or if you add additional classificator here, this vector will be common for 3 tasks. Yeah, and using 3 heads or 3 classificator, you can find more precise feature, or maybe more closure feature, which can solve the task for 3 classificator. Yeah, maybe some more interesting feature vectors here. So and your neural network will be consist of one convolutional neural network, yeah, and you use this feature vector for 3 tasks. But in your picture, you draw a bit, I guess, another. You just write some neural network, and you write that feature vector, some feature vector here, some feature vector here, and some feature vector here, yeah. But it is not correct way for solving the task. For example, for gender, you can't use different feature vectors, and how you can get them. How you can get them, and using just one neural network for gender, for race, and for age classification, because this is like a bottleneck maybe, because it's not good way. Better if you use different classificator for race, age, and gender, but using just the one feature vector, which was extract from your convolutional neural network. So this is a correct way for solving this task. Okay. Let's see that view. Send me. Okay, here you can find that this one is the best, but of course you can use model from here, yeah, because you just train your model and the weights now stay in this point, that this weights which was get from your training now return such accuracy, such loss value. Yeah, but of course better if you stop your training earlier, something here. For this you need to limit your number of apple. I guess that now you determine number of apple 40. But maybe it will be better if you use 35. And I guess that maybe it will be more useful for you if you can use torch. Say this is important moment. Always you can save and load in models. I guess that it will be useful for you if you read this small article how you can save the weights model. Yeah, here is some simple line. Here you can save model. Stay dict means that you just saving the inference model or weights, and you can always load these weights into your model and compare them. So in this task maybe it will be better if you train your model, save weights, and on the next step, using another notebook, you compare these 3 head models with 2 heads and with 1 head model. Yeah, it means that using accuracy, yeah, just calculating this block. I mean that you train best model. You know that this point means that you have the best model, and save your model, and save using save model state dict, and pass means that you determine the name of your model. There is another way, save load entire model. It means that you save weights and architecture and etc. And here you just save, and of course you can load again and compare them together. For example, you in another notebook, here you torch save Okay, we can just get from here, yeah, Control C, Control V, but model code network, yeah, network here. Something like this, you write model your network, and here you can write that model with free classificator, yeah, and here is a class like this, and you save your model, and after this you can create new notebook where you load this model and compare with other. I mean that you will have different, okay, maybe we can run and just check. Second. It's right here. For instance, give with age, gender, races. Something wrong here. So, part 1. Part 1. Okay, let's start here. Okay, now we train the model. Some training, yeah, and we can save model weight, and now, okay, let's try maybe. Let's try create new notebook. Okay. Create new notebook. Okay, we need to, I guess, that we download it. Download this model. And we upload. Okay, now we have a model here, and just getting torch model class. Okay. Import. Let's try to import file. Sorry, I have a problem with my keyboard. Torch and yes. Model with age, gender, race. Okay, can get attribute in CNN model. Okay, there is some problem here. Model frame. Okay, we need to import all class, and I guess we put that to this one. Let's try again, and here will be CNN. Here is CNN model. And load fast, load. And PC. And okay, if you are running this social map location CPU. Yeah. Let's try again. Has no attribute copy. Model. Try to use this one. reference model. Model is not, there is network. Network, we say model, okay, we need to remove the previous model, and load. So upload. Loading station and missing keys. Gender F. Okay, there is some problems with how it can be. You see that something wrong. Something wrong. Arrays classification, how many classes? 4 or 5?
I write 5.
Yeah, 5, okay. So, there's something wrong here. Yeah. Okay, let's copy it and run and CNN model FC2 gender 2. I guess that I made a mistake here and something wrong. Okay, FC2 linear 50, and here should be 50, yeah? Race here should be okay, 50, 80, 80. This is okay, yes, something like this. Copy and model should be the same, but the model not the same. Age. Gender here. Correct. Okay, nice. So now we can load weights into our model, and everything is correct. So we create a model with default weights, and after this we just upload our weights from the 8 gender address classification into our model. And change states of our model as evaluation. And of course, you can create more than one model, yeah, and store all model 1, 2, 3, and etc. and compare them together. Means that you can evaluate accuracy for model 1. For model 1, for example, here, yeah, you train your model. You can find the best weights for your model and save the weights. After this, you can use these weights for upload or for creating your model in another notebook for comparing, not for training, just comparing. And here, for example, it will be model 1, yeah, model 1, evaluate. And another weights will be the another model, for example, second. And it will be another model and it will be another class. For example, if you have the model 2 should classify only gender, yeah, you will get correct architecture and upload the weights, for example, with model with age here. And after this, you plot such graphics, and of course you can combine graphics together. For example, accuracy from the model 1 for gender and accuracies for the model 2 with gender, yeah, and you can find which model better for you. This is the one way how you can compare them together. Just saving all weights. Okay.
Okay, Professor. I try it in next week.
Okay.
But please send me update this.
This one, yeah.
Yes.
Okay. May I file save copy on this?
Two notebooks.
Okay. File save. Okay, and need to open this. Drive. Okay, this one remain. Load model. Okay, and load model. And copy.
Okay, maybe do you have any questions in this task?
No, thank you, Professor. For me, no.
Okay, or maybe we can go to the Hun. Hun, what do you want to show us? Hun, do you hear me? Hun. Can you hear me? Unfortunately, I can't hear you. Okay, I sent your homework at the chat for next week. Okay.
Yes, I see.
Okay. Okay. And Hoon, do you hear us or not? Do you want to show us your result this week or not? Hoon? Unfortunately, I can hear you.
Okay, I upload them in folder tasks.
Okay.
Okay, thank you very much, Vasily. Thank you very much, Ali.
Thank you, Professor.
Hoon, do you want to show us your results this week or not, maybe? I don't understand. Can you hear us? Unfortunately, okay, if you have any questions, please send us message. Okay.
Okay.
And please be ready for next week with semester report plan. Okay.
Yeah.
Okay. And I think all for today.
Yes.
Okay. Thank you. Goodbye.
Thank
Bye.
you, Professor. But please remember Professor Mikhail about
Yes,
link
yes.
YouTube.
Of course. I sent him mail. Okay.
Yes.
Of course.
Thank
Of
you.
course.
I think, Professor, today we have a
Yes.
lecture in image processing.
Yes, yes, yes. Of course, you have lecture with Professor Mikhail Ronkin, of course.
Yeah. He's my
Yes.
colleague.
Okay, okay,
Okay. Thank you. Goodbye.
okay. Goodbye.
Thank you. Bye.
Goodbye.